name is Deanna Smalls, and I'll be doing Chapter 17, Problem number 12. This section of Chapter 17 deals with diffraction. Diffraction is the bending of waves over an obstacle or an opening. And if given the width and the wavelength, you can find the angle theta of the wave. Depending on what shape opening it is, either a rectangular or circular opening, depends on which formula you use to find theta. So going to the question that deals with this, it asks, a speaker has a diameter of 0.3 meters. And part A says, assuming that the speed of sound is 343 meters per second, find the diffraction angle theta for a 2.0 kilohertz tone. And question part B asks, what speaker diameter D should be used to generate a 6.0 kilohertz tone whose diffraction angle is as wide as that for the 2.0 kilohertz tone found in part A. So these are our givens. Our first width is 0.3 meters. Our speed of sound D is 343 meters per second. Our first frequency for the first part of the problem is 2 kilohertz. Our second frequency for the second part of the problem is 6 kilohertz. And for part A, they want us to find theta. And for part B, they want us to find the new width. So these are the formulas we'll use. V, which is speed, is equal to lambda times frequency. And sine of theta is equal to 1.22 lambda over D. We use this equation because it says it's a speaker, so it has to have a circular opening. And this is the equation you use when you have a circular opening. So before we can, in order to find theta in part A, we have to derive this first equation and find lambda first. And we derive it into lambda is equal to V over F. And so with that, we can plug in what we were given. So for part A, lambda is equal to 343 meters per second over the converted units of 2.0 times 10 to the third hertz. And from that, we get that lambda is equal to 0.17 meters. Then we can plug that into our sine of theta equation to find theta. So sine of theta is equal to 1.22 times 0.17 meters over 0.3 meters. And that gives us the number 0.697. We now have to find the inverse sine of this number to find the actual angle. So inverse sine of 0.697 gives us an angle of 44.22 degrees. So the second part of our question says to use this diffraction angle to find the new width that has a frequency tone of 6 kilohertz. So once again, we have to find the wavelength at this frequency. So lambda is equal to 343 meters per second over the converted of 6 times 10 to the third hertz. And that gives us a wavelength of 0.057 meters. Then we have to plug this into our derived formula to find the new width. So D is equal to 1.22 times our new wavelength, 0.057, over our sine of theta, which we found to be the first one as 0.697. And from that, we find that the new width is equal to 0.1 meters.